everybody. This is going to be the first section from chapter 10, 10.1, and I put it in with chapter 6 because it talks about quadrilaterals and polygons, and it goes along with our quadrilateral unit for chapter 6. So we'll look at 10.1 and 10.2 with chapter 6. Again, the first section we're going to do is 10.1. We're going to look at angle measures of polygons and then tessellations with polygons. All right, so far we have looked at triangles, and we know all three angles in a triangle equal 180. We've also looked at quadrilaterals, and we know all four angles add up to 360. And we talked about kind of how many diagonals you can draw from the vertex. Tells you the number of triangles in the figure, and then you can figure out the number of degree measures. Now you don't always have to do that. There is a formula available. So to find the sum of the interior angles of any polygon, and it's any convex polygon, you're going to take the number of sides, subtract 2, and then times it by 180. So you would take the number of sides times it, you're going to take the number of sides, subtract 2, and then times that by 180 to find the measure of the interior angles of a convex polygon. Now, if your figure is not a regular polygon, we can find the sum of the angle measures, but we can't necessarily find out what each angle inside equals without more information. However, if we have a regular polygon, remember, regular polygons, all the angles inside the polygon are the same. So I can figure out the sum of the angle measures by doing the number of sides minus 2 times 180, and then divide by the number of sides, divide by n, or multiply by 1 over n to get what each angle would equal. All right, here they want us to find the sum of the measures of the interior angles of a convex octagon. So if you recall, an octagon has 8 sides. So n is going to be 8. And to find my measure of, or my sum of interior angles, it's going to be n minus 2 times 180. So I will do 8 minus 2 times 180. So it's going to be 6 times 180. And when I multiply that out, the sum of the interior angles of a convex octagon are going to equal 1080 degrees. All right. So here they want us to find the measure of the interior angle, and or they want us to find the value of x and then find the measure of angle A and measure of angle B. Now, I can take all my angles and add them up. So I know F, because it's marked that way, is 90. And then A is x plus 20. B is x. C is 135, D is 90, and E is 125. But I don't know what they equal. This figure is, let's see how many sides it has. It has 1, 2, 3, 4, 5, 6 sides. So it is a hexagon. It's a 6-sided figure. So to figure out what my equation needs to equal, I need to figure out what the sum of the interior angles of a hexagon equal. So if we do 6 minus 2 times 180, that's going to give me 4 times 180, and that will equal 720 degrees. So now my equation is going to equal 720 degrees. And I can solve my equation. I need to combine like terms. So when I do that, let's see. We just have 2x plus, if I add all my numbers together, I'm going to get 460. And that's equal to 720 because I added 90 plus 20 plus 135 plus 90 plus 125. solve my equation, so I'll subtract 460 from both sides. So now 2x is equal to 260 divided by 2, and x is going to be 130. So I can use that to find my angle measures. If I know b is equal to x, so b is equal to 130, and then a is going to be 130 plus 20, so that's going to be, for the measure of angle A, it's going to be 150 degrees. All right, so here they want us to find the measure of each interior angle of a regular hexagon, and they are looking at the side of a building that was built in China to look like, or the panels were hexagons. So we want to figure out the measure of each interior angle. And remember, it's a regular hexagon. So that means that all the angles on the inside are the same measure, all 6 angles. Now, we did just figure out a hexagon has 6 sides, and we just figured out in the last problem that all 6 sides add up to 720. So what I can do is, to find the measure of each angle, I can take that 720, which again, remember, I got by doing 6 minus 2 times 180. I can take my 720 divided by 6, and that is going to give me, each angle in a regular hexagon is going to equal 120 degrees. All right, next we are going to find how many sides a polygon has if the measure of an interior angle of a regular polygon is 144 degrees. So that means each angle on the inside of this polygon is equal to 144 degrees, and they want us to figure out how many sides the polygon has. So remember, if it's a regular polygon, to find the number of degrees, we would do n minus 2 times 180, and then divided by the number of sides, and it would give us the measure, which we know is 144. So now we got to solve this equation to figure out what each side is equal to, or what n is equal to. So I want to get rid of this fraction first. Since they divided by n, we are going to multiply both sides by n, or think of it as n over 1. So that'll cancel out my n's. On this side, I have n minus 2 times 180, and it equals 144n. That's an n there, okay? And then you could either distribute your 180 and solve from there, or I just want to get rid of the 180. So I am going to, you could start by dividing, or we'll go ahead and we'll just distribute. We'll make it a little bit easier. So I'm going to have 180 n minus 360 is equal to 144n. So then I'm going to, I'll subtract 180n to get my n's on the same side. And that is going to give me negative 360 is equal to negative 36n. We're going to divide by negative 36. And that will cancel out on that side. The 2 negatives make a positive. Negative 36 divided by, or negative 360 divided by negative 36 will give me 10. So that means that our regular polygon, where each angle measures 144 degrees, is a 10-sided polygon, or a decagon. Okay, here we're going to talk about exterior angles. We looked at them with triangles, and again, we're going to look at them with polygons. Again, there are multiple exterior angles that form vertical angles, but we are always going to look at just one exterior angle for each vertice in our polygons. So again, like this picture is what we're going to do. All right, now we're going to look at a theorem, the polygon exterior angle sum theorem. And this theorem says that the sum of the measures of exterior angles of a convex polygon, one exterior angle at each vertex, is 360. So it doesn't matter how many sides your polygon has. If you measure the exterior angle, one at each vertex, and you add them all together, you will always get 360 degrees. Doesn't matter if it has 6 sides, 3 sides, 100 sides, 12 sides, it will always equal 360. Now, the corollary to that is if you have a regular polygon with an exterior angle, remember, regular polygons, all the angles are the same, so we can find the measure of each exterior angle. Just take 360 and divide it by the number of sides. All right, so here we have a polygon, and we want to find the measure of each exterior angle of a regular polygon. So again, we know all 5 angles here are always going to add to 360. We want to find the measure of each angle, so I'm just going to take my 360 degrees and divide it by 5, and when I do that, we are going to end up with each exterior angle in my regular pentagon is going to equal 72 degrees. All right, now I want to find the measure of each exterior angle in our regular polygon. The polygon is a 1, 2, 3, 4, 5-sided figure again. Excuse me, it's not a regular polygon. It is, so we're not finding the sides. We're not finding the number of sides in the regular polygon. It's a polygon. But we want to find the measure of each exterior angle. So that means that we are going to take all my angle measures, my exterior angles. So I'm going to start here and I'll work my way around. We have 2x plus 2x plus x plus 5x plus 3 plus 4x plus 7. And we know no matter how many sides, they're always going to add to 360 degrees. So now we can combine our like terms. And when I add them together, 2x plus 2x is 4, another x is 5, 5 more will be 10, and 4, so we have 14x plus 3 plus 7 will be 10 equals my 360. So I'm going to subtract 10 first. Then I get 14x equals 350. I'll divide by 14. So x is going to equal 25. And then they want us to go back and figure out the angle measures of each angle. So if I know if x is 25, this angle right here is 25. 2 times 25 will give me 50. And that will be the same for both of those. And then 4 times 25 is 100 plus 7 will give me 107 degrees. And then 5 times 25 is 125 plus 3 will give me 128 degrees. All right, the last thing we're going to talk about in this section, the last few slides are going to deal with tessellations of regular polygons. And a tessellation is a tiling pattern with no gaps or overlaps. And the sum of the angles where the polygon meets, or the polygons meet, we're always going to be 360. So think of any tiling pattern that you see That's a tessellation. There are also famous artwork pictures out there. There are tessellations, and you find tessellations a lot in nature. And we're going to look at some different examples of tessellations. Again, a tessellation is a tiling or a repeating pattern, and it's always going to completely cover a plane without gaps or overlap. It can be made of polygons, in which those polygons will come together to form those 360 degrees if it's regular polygons, or figures from your imagination. But again, they apply or they happen in nature. We see them every day. Whenever you see a tile pattern, it's a tessellation. A brick pattern on a house is a tessellation. There's lots of them out there. The shingles on a roof can form a tessellation as well. Here are two just examples of tessellations. The first one with the fish is like a quilt pattern that was found, and that's a tessellation. And then the octopus or octopi in the second one form a tessellation. Each of the patterns or the shapes interlock, but they don't overlap. So you could cut out each individual one and put it back together as a puzzle if you wanted to. But it is a tessellation. Next, we have some tessellations that you might find in nature. So a pineapple, the scales or the skin on the pineapple form a tessellation pattern. The scales on a snake tessellate, and then a beehive, the honeycombs, also form a tessellation, a hexagon pattern. All right, and the last thing here we're going to look at to see is this picture here, right here, this picture, does it make a tessellating pattern? It's made up of different equilateral triangles. And again, remember where the triangles meet, it should form 180 degrees. And we're going to take a look at the next page to kind of take a look and see if it equals the 360. All right, so again, we know with a triangle, an equilateral triangle, all angles equal 60 degrees. So the measures of angles 1, 4, and 3 are angles in an equilateral triangle. So they are going to equal 60 degrees. And then angle 2 is a straight angle because it's on the side of the triangle. So it's going to equal 180. And if I add 180 plus 60 plus 60 and 60, you do get 360 degrees. So even though we have 3 different sizes of triangles here, they do form a tessellation, and they are a tessellating pattern.